This video will demonstrate how to use the redox half reaction method to balance a redox reaction in a basic environment. The first step remains the same. Separate into two half reactions, each of which are capable of being balanced. In this case, we can take the SN4 plus yields SN2 plus as one of these. And the second half reaction really only has oxygen to be balanced. So the first step, where we balance all of the matter that does not involve oxygen or hydrogen, is already done, and we can move to the second step, which is to balance out oxygens by adding in water. In this half reaction, we again have nothing to do. In the second half reaction, we must add water as a reactant, and that now has all of our mass balanced except for the hydrogens. The hydrogen mass balance step remains the same. We add in H plus to balance out any hydrogens that were thrown out of whack by adding in water in the previous step. And in this case, we will need to add H plus as a product. Now all of the matter is balanced. We only need to balance the charge. We have plus 4 and plus 2. We add in electrons. We're going to need 2 of them here. This will bring this to a plus 2 to match that plus 2. Here we have minus 1, and minus 1 plus 2 gives us a plus 1. In order to bring the plus 1 down to minus 2, we add in 2 electrons here. Now that all of the matter is balanced and all the charge is balanced, we have to prepare everything to be recombined. This requires a multiplication to guarantee that the electrons we have as reactants are the same in number as the electrons we have as product. In this case, because they're both 2, we only need to multiply by 1 on both of them. And at this point, I'm able to simply write everything out. So make sure we get that correct. And here we have H2O. Our second half reaction. And it's straightforward to verify that these 2 electrons and these 2 electrons will cancel each other out. And now, because this is done in a basic environment, we have one additional step, and that is to add hydroxides equal in number to the number of hydrogens. So I add 2 OH on both sides. And that OH minus and H plus will combine to form water. So because we have 2 each, we have 2 waters on this side, canceling the 1 water on this side. And when we bring everything back up to the top, we find that we have to make a couple of adjustments. The first is that we have a new species here, and we have our water here. And then we want to copy over all of the remaining changes to coefficients. And in this case, we have none. Everything remained 1. And you can look at this and verify for yourself that this is, in fact, completely balanced redox reaction using the redox half reaction method.